Hello everybody, we're getting ready to do lesson 4.3 part 1 of pre-calculus math today. If you need to get a hold of me, email me here for note-taking guides and other video, PowerPoints, other instructional materials. 4.3 right triangle trigonometry part 1. We got 68 points here of classwork to do today, and no points for your notebook taking on this part of the lesson. Teachers, we're going to start out with your bell work today. We got a situation here where you're going to, students can use a graphing calculator to construct a table of values for these functions. Here, these two functions. Then sketch the graph of the function, and then identify any asymptote of the graph. Students, so use your graphing calculator for that. Give your students about 6 minutes for that. Okay, welcome back everybody for your solutions for our bell work today. 10 points on this bell work, and then up here for this function here are your table of values for each of the 3x. And then this is what your graph should look like here. Sketch that in here on your grid. And then the horizontal asymptote in this situation here would be your x-axis, or y equals 0 for your x-axis for 91. And then 92 here are your table of values for the negative of each of the 3x. And then this will be your function here, a falling function here to the negative part of that. And then your asymptote here will be, you have a horizontal asymptote of y equals 0. This comes up close to your x-axis here, but it does not cross your x-axis. So this is your horizontal asymptote, would be your x-axis. Okay, into our lesson today, classwork page 1, right triangle trigonometry. There's 6 trigonometric functions. Our second look at trig functions is from a right angle perspective, a right triangle perspective here. And then we have a right triangle here, 90 degree here, and then our hypotenuse is here, side opposite theta, and then side adjacent to theta, adjacent, opposite, and then your hypotenuse. The relative to the angle of theta. So consider a right triangle, one acute angle labeled theta. Relative to the angle theta, the 3 sides of the triangle are hypotenuse, the opposite side, and the adjacent side. So we have adjacent side, opposite side, and then your hypotenuse there. Using the lengths of these 3 sides, you can form 6 ratios that define the 6 trigonometric functions of the acute angle theta. So we have sine, cosine, tangent, cosecant, secant, and cotan here. In the following definitions, it is important to see that we're going to be only considerate here of the functions within the first quadrant here, which is between 0 degrees is less than theta and theta is less than 90. So it will be our quadrant number 1 is what we're concerned with here for our trig function. Okay, theta lies in the first quadrant, and that for such angles the value of each trigonometric function is positive because you have a positive y and positive x. Right triangle definitions of trig functions. So let theta be an acute angle of a right triangle, then the 6 trig functions of the angle theta are defined as follows. Note that the functions in the second column are the reciprocals of the corresponding functions in the first column. So we have sine theta is opposite over the hypotenuse, and then cosecant, which is the reciprocal of sine, would be the hypotenuse over the opposite. So in this situation here is our right triangle, adjacent, then opposite. Our acute angle would be here. So a cosecant for theta would be the hypotenuse over the opposite, and then sine would be the reciprocal, the inverse of that. And then cosine theta would be adjacent. So it would be the adjacent over the hypotenuse. And then secant, which is the inverse of cosine, would be the hypotenuse over adjacent. And then for tan would be opposite over adjacent, op over hype. And then cotan would be adjacent over, be opposite over adjacent. And then cotan would be adjacent over the opposite, adjacent over the opposite. So there are your 6 trig functions for using a right triangle to elaborate those within the quadrant number 1. Okay, abbreviations are op, adjacent, adj, and hype for our functions here. Represent the lengths of the 3 sides of a right triangle. So opposite equals the length of the side opposite. Theta, here's theta, and then this will be opposite here, so it'll be directly across from theta. That'll be your opposite side. And then the side that is part of one of the sides that make up the theta angle would be the adjacent side to theta. And then the hypotenuse will be the length of the hypotenuse. It is adjacent to theta, but it's key because it's opposite of your 90-degree angle, your right angle on your triangle. So that's key. The hypotenuse is key. Example 1, evaluating trig functions. So we have our right triangle here, 3, 4, and then we have our hypotenuse. Use a triangle to find exact values of the 6 trigonometric functions of theta. So, we're going to use the Pythagorean theorem. The hypotenuse squared equals op squared plus adjacent squared. It follows that the 6 trigonometric functions are, here they are. So sine be 4 over 5. We got 4 over 5. We know it's a 3, 4, 5 right triangle. And then cosine theta would be 3 over 5, 3 over 5. Tan would be op over the adjacent, so it would be 4 over 3. And then cosecant, which is our inverse of our sine, would be 5 over 4. Secant, which is the inverse of cosine, would be 5 over 3. And then cotan, which is the inverse of tan, would be 3 over 4. So that would be how that would work, using again our right triangle here in the first quadrant to elaborate these functions. Okay, our first guided practice here. Find the exact values of the 6 trig functions for this triangle here. Students, this is yours down here. So I'm not sure if I do this one for you today. I might. But up here for our 8, 15, and then what is our, I guess our hypotenuse is 17. For in this situation here, here's our sine, which is op over hype. So it's op, it'd be 8 over our hype here, which is 17. Cosine would be adjacent over our hype, 15 over 17. And then for our tan, it'd be op over adjacent, it'd be 8 over 15. And then for our inverse functions here, the cosecant would be hype over op, so it would be 17 over 8. And then secant would be hype over the adjacent, so it would be the hype over the adjacent. And then for cotan, it would be our adjacent over our opposite, 15 over 8. So by using this as a model here, students, I think you should be able to do your independent here. So go ahead and do that. Do that for you. I don't, so I expect you to do that on your own or within your study group. So example 2, evaluating trig functions of 45 degrees. So we got, instead of a 30, 60, 90, we have a 45, 45, 90 is what we have. So we have a 45 here, 45 here, and then here's our 90 here. Here's our side lengths, and then here's the length of our hypotenuse. Construct a right triangle having 45 as one of its acute angles. Okay. And choose one as the length of the adjacent side. So Our side lengths are 1. From geometry, you know that the other acute angle is also 45, so the triangle is isosceles, and the length of the opposite side is also 1. Using the Pythagorean theorem, you can find the length of the hypotenuse to be square root of 2. So again, using this 45, 45, 90 triangle, our sine here would be op over hyp. So our sine would be op over hyp would be 1 over square root of 2. And then our cosine would be adjacent over hyp, would be the same thing, square root of 2 over 2. Remember to rationalize your denominator. And then the tan would be op over adjacent, would be 1 over 1, would be 1. Okay, so let's get into our guided practice here. So we're dealing with 30, 45, and 60 degrees as our angles for a right triangle. And again, this will be in the first quadrant here. So in this situation here, we have a sine function with a 30-degree angle. How many radians is that, and what's the function value of that is what we're trying to find here. Students, this is yours down here, and then here's a model here for you to use. In this situation here, we're using this angle up here, this 30-degree angle, to find the sine of that 30-degree angle. Okay, so radians, 30 degrees is pi over 6 radians. And then the function value here for sine would be the opposite over hyp, which would be 1/2. So it would be the opposite here, your 30 degree would be 1 over your hypotenuse would be 2. Down here from your 60, I'm going to let you do this on your own, students, so go ahead and do that. Oh, I guess not. I give you pi over 3. I'm going to help you out on this one. Check yourself on this one after you attempt it. So 60 degrees is pi over 3 radians. And then the function value here is cosine would be adjacent over height. So it'd be 1 over 2 as well. So it'd be 1/2. So cosine of 60 degrees be pi over 3 radians, and then a function value of 1 over 2. Let's go into another example here. Example 3, evaluating trig function 30, 60, 90. Here, so here's our 30, 60, here's our 90. So use the equilateral triangle to find exact values of 60 degrees. So we're going to find exact values from this angle here. So cosine 60, sine 30, and cosine 30. So we're going to find exact values of sine 60, cosine 60, sine 30, and cosine 30. So by, again, using a Pythagorean theorem and the lengths of the sides, for theta equals 60, you have adjacent equals 1. Here's your adjacent side. And then your opposite side would be square root of 3 over here. And then your hypotenuse would be 2. So sine 60, which is your opposite over your hypotenuse, would be square root of 3 over 2. And then your cosine 60 would be the adjacent over your hypotenuse, would be 1 over 2. And then for theta equals 30, your adjacent here in this situation will be your square root of 3 side here. And then your opposite would be 1 here. And of course your hypotenuse still be 2. So in that situation, for a 30-degree angle, our sine 30 would be 1 over 2, so opposite over hypotenuse. And then our cosine 30 would be adjacent, be our adjacent, which is here. Here's our adjacent side, over our hypotenuse, which is 2. So that would be your functions there for your function value for cosine over 30 degrees. Okay, into our guided practice. We need to find our tan now for, and we don't know yet, but it's pi over 3, which is a 60 degree, so we know it's tan 60. So tan 60 here. And then tan is what? It's opposite over adjacent, correct? So you know tan in this situation here is of our 60-degree angle. So it'll be 60 degrees, and tan again is our opposite over adjacent. So it would be square root of 3 over 1 will be our opposite over adjacent. So it'll be square root of 3 over 1. And then down here we have a secant function here to evaluate. We have pi over 4. So pi over 4 we know is 45 degrees. So that's 45 degrees. So what would be the value, the function value for a secant function for a 45 degree? Secant is the inverse of cosine. So cosine is would be adjacent over hypotenuse. So the inverse of that, so it'll be 1 over square root of 2 would be the cosine. So the secant would be the hypotenuse over the adjacent. So it'll be square root of 2 would be your function value for the secant of this triangle here. And that is your 4.3 Part 1 of Pre-Calculus Math. Email me here for questions or other materials for the course. Thank you very much.